Hi, so welcome to the tutorial on logic in kind of using a more computer programming platform. So if you click on the link below this video or simply just go to the Logic Lab, is what you'll see is this will pop up. It's a free platform, and what it does is it's able to use logic ports in creating some cool stuff. So the first thing you're going to want to do is on the left side is kind of all the stuff you can work with, and in the middle here is kind of your building area. So if I first, so I'll show you quickly how an AND works in a different way. If I was to bring two switches over, and you can see I can toggle the switches on and off. Red means on, white means off. And I'll grab a logic port and I'll put an AND in. And then what I'll do is I'll put an output, say a motor on the other side. So what I'm going to do now is to connect them, is you just click the arrow, drag it over to the AND. This is kind of the statement the AND is going to check. And then it's going to output, if it's a true statement, if it outputs a true, the motor runs. And if it outputs false, then the motor doesn't run. So in a sense, this port, because it's off, is running false. This is running false, so false and false implies false through an AND. If I turn one on, you'll notice now we have false and true, which is of course using an AND port, is still false. The moment I turn the other one on, you'll notice, because it's this one and this one, it runs a motor. So what I'm going to do is I'm just going to pause the video and I'll just get another one set up. So now you'll see that I've put an OR port. So what will happen in this case, this is now true or false is actually true. If it runs, true or true is still true. And of course, false or true is still true. And lastly, false or false is actually false. And the last one here is a NOT statement. Now the NOT only has one implication because it's not as AND and OR you need two statements. This is just a one statement. So as you can see, it's false. Not false means true. And of course, not true is false. So what we're going to do here is I'll just kind of go through the things. Here's a button. So this is kind of a little more difficult. I like using the switches because you can toggle them on and off. If you have two buttons, say, on your screen, it's impossible from what I know to push them both at the same time. So we can use switches. We can even use, if you have a microphone, you can actually embed, so if it hears sound, this will run true. And if we go down to flip-flops, we are not going to use flip-flops, as we're not going to take into account in this kind of mini course. But under logic ports, I will talk about kind of these other ones. So I've showed you the AND. The NOT AND is, in a sense, is if you wanted to, is if there was an and after the AND, we put a NOT. So how this works is exactly how this circuit would work. If the AND is true, then the NOT AND would run false. And if the AND was false, the NOT AND would run true. This is the same thing with a NOT OR. This XOR is what we call an exclusive OR. So an exclusive OR is, if you'll see, is, well, in a sense, is one or the other, but not both. So if I was to connect these, it runs like a regular OR as this. True or false is true. False or true is true. However, in this case, true or true is now false. Now, exclusive ORs will run in the Logic Lab, but in the tutorial around the mathematics is we really don't deal with exclusive ORs. Usually when we have an OR in mathematical logic, it's usually implied that it's an inclusive OR, meaning that if these both were true, this will also be true. So you can feel free to use this in building your car, but we're not going to really cover this in the mathematical logic when we're dealing it with pen and paper. The last one is obviously an exclusive NOT OR. So this would flip. If the exclusive OR was true, the exclusive NOT OR would be false. And if the exclusive OR was false, then the exclusive NOT OR would be true. So the last thing is we have these extras. Extras will be as if you wanted to do one input, one switch that controls three. Okay, so if this is true, all three of these are true. Just think of this as a splitter. Another one is a timer. If you can run the time, you can play around with that. And the outputs we're going to use are lights. So this is a light. Obviously, if the true comes, the light comes on. When the switch comes off, it's false, so the light does not come off. And the last one would be this. If you want to get a little more complicated, this is a binary counter, so depending on the parts, it can count up to 8. And after that, I will let you play. So If you want, I will show you a clip later on kind of how to build the beginning of the car. But for now, I want you to try the first assignment where you have to build a car. And if you have not driven before, how a car works is the following. We'll say, as always, the right pedal if you're kind of looking at it from this point of view. This would be gas. So if this was gas, I'd want all 4 tires going. As soon as I let go of the gas, all 4 tires stop. If I hit the gas, but then I hit the brake at the same time, we're going to assume that the car stalls, so all 4 tires stop. And of course, if I let go of the gas and just hit the brake, all 4 stop. And if nothing are on, all 4 stop. So the only time it's running actually is in this position, which should be kind of a hint on how you can start. And so one last thing is, this is kind of the template I want you to start with. Gas, brake, tires. So I'm leaving it up to you what goes all around here, what logic ports, where you should run wires. But like I said, it should run like a regular car.